So what is a diagonally dominant system of linear equations? We have three equations in variables x, y, z, and all these three equations are linear. And we have to check that if this system of equations composed of equation 1, 2, and 3 is a diagonally dominant system or not. Now the system of linear equations is called diagonally dominant if the diagonal coefficients are greater than absolute sum of the remaining two coefficients in the respective equations. Meaning that, let's say the diagonal coefficients are 9, 12, 8. These are called the diagonal coefficients of the diagonal variables. Now the diagonal variables are x, y, and z. So their coefficients are 9, 12, and 8. Look at the first equation. The diagonal coefficient, which is 9, its absolute value should be greater than the absolute sum of the other two coefficients in that equation. The other two coefficients are 2 and 3. So absolute 2 and absolute 3. Now let's look at the second equation. The diagonal coefficient, which is 12, along with the diagonal variable y, diagonal coefficient 12, its absolute value should be greater than the absolute sum of the other two coefficients in this equation. The other two coefficients are 6 and minus 1. So 6 and minus 1. Now look at the third equation. The diagonal coefficient is 8 along with the variable z. Its absolute value should be greater than the absolute sum of the other two coefficients in that equation, which is 2 and 2. Now let's check that if all these three conditions are true, we will say that our given system is diagonally dominant. So from the first inequality, we have 9 should be greater than 5. Second inequality says that 12 should be greater than absolute 6 is 6 and absolute minus 1 is 1. So it should be greater than 7. The last inequality says 8 should be greater than 4. So all these three inequalities are true. So we'll say that this given system of linear equations is diagonally dominant. Let's look at one more example. We have a system of linear equations 3x plus 10y minus z is equal to 0, 5x minus y minus z is equal to, let's say 5, 2x plus 6y plus 9z is equal to 7. Now we will check that if this given system is diagonally dominant or not. So in the first equation, the diagonal element along with the variable x is 3. Its absolute sum should be greater than the absolute sum of the rest of the two coefficients in that same equation. So we can see that in the first equation, the diagonal coefficient is 3 and the other two coefficients are 10 and minus 1. So that's the first condition. And the second condition is the diagonal coefficient in this case is minus 1. So minus 1 absolute should be greater than the absolute sum of the other two coefficients, which are 5 and minus 1. And the third condition says that the diagonal coefficient, which is 9, its absolute value should be greater than the other two absolute coefficients, which are 2 and 6. Let's check the first condition. It says that 3 should be greater than 11 because minus 1 absolute is 1. 1 plus 10 is 11. The second inequality says that 1 should be greater than 6. And the third inequality says that 9 should be greater than 8. Only the last inequality is true, but the first two inequalities are not true. So we will say that this given system is not diagonally dominant. Now again look at this given system of equations. We are going to switch the places of the rows to see that if we can make this not diagonally dominant system as the diagonally dominant system. So what shall we do is we will switch the row 1 with the row 2. Means we will write the second equation first, which is 5x minus y minus 10 equal to 5. And we will write the first equation next, which is 3x plus 10y minus z is equal to 0. And the last equation will be in its own place. 3x plus 6y plus 9z equal to 7. Now after switching the places of the first and second equation, we will check that if now the system is diagonally dominant or not. So for the first equation, the diagonal coefficient is 5. 5 absolute should be greater than absolute sum of the other two coefficients, which are minus 1 and minus 1. And in the next equation, the diagonal coefficient is 10. It should be greater than 3 absolute plus minus 1 absolute, because 3 and minus 1 are the other two coefficients. And in the third equation, 9 absolute should be greater than 2 absolute plus 6 absolute, because in this equation 2 and 6 are the other two coefficients. Let's check that. First inequality gives us 5 should be greater than 2. Second inequality gives us 10 should be greater than 4. And the third inequality gives us 9 should be greater than 8. All these three inequalities are true. So we will say that yes, this system of equations is diagonally dominant. So the point is, look at this system. Initially this system was not diagonally dominant, but when we switched the first equation with the second equation, this became the diagonally dominant system. So sometimes if initially the system is not diagonally dominant, by switching the places of the equations you can make it diagonally dominant. Let's look at one more example. We have a system of equations x minus y plus 10z is equal to 0, 2x plus 2y plus 7z is equal to 0, 3x plus y minus z is equal to 0. Let's check that if this system is diagonally dominant or not. So from the first equation, the diagonal coefficient is 1 along with the variable x. So 1 absolute should be greater than the other two coefficients, minus 1 absolute plus 10 absolute. And the second equation, here 2 is the diagonal coefficient. Its absolute value should be greater than the absolute sum of the other two coefficients in this equation, which are 2 and 7. And in the third equation, the diagonal coefficient is minus 1. It should be greater than an absolute sum of the other two coefficients, which are 3 and 1. Now let's check that if these inequalities are true or not. First inequality gives us 1 should be greater than 11, not true. Second inequality gives us 2 should be greater than 9, not true. The third inequality gives us 1 should be greater than 4, not true. So we can see that this system is not diagonally dominant. Now the question is, can we make this system, which is apparently not diagonally dominant, a diagonally dominant system by switching the places of the equations. Let's do that. We switch the first equation with the third equation. When we do that, so the third equation comes up 3x plus y minus z equal to 0, and the first equation comes in the place of the third equation. X minus y plus 10z is equal to 0, and the second equation remains in its place. 2x plus 2y plus 7z is equal to 0. Now let's check that if making this change we can have a diagonally dominant system or not. So this equation gives us 3 absolute should be greater than 1 absolute plus minus 1. This equation tells us that 2 absolute should be greater than 2 absolute plus 7 absolute, and the third equation tells us that we have to have 10 absolute should be greater than 1 absolute plus minus 1. Let's check these inequalities if they are true or not. The first inequality says 3 should be greater than 2. The second inequality says 2 should be greater than 9, and the last inequality says 10 should be greater than 2. So first inequality is true and the second inequality is true, but not the second one. So again, when we made the changes in this not diagonally dominant system, we got this system, and even after making these changes, means even after switching the places of the equations in the not diagonally dominant system, we cannot make this system diagonally dominant. So we will simply say that the given system of equations is not diagonally dominant. So this is how we check the diagonal dominance of the given system of equations. So this condition of diagonal dominance is important to ensure that the solution of the system of linear equations exists using the iterative methods.